So let me start from monotonic transformation. So you have a function u is a function of x1 and x2. So suppose we transform the function. We take square or we take log, we divide by some number. So we transform the function in such a way that f prime u is positive. The advantage of this is that in this case, the ranking is preserved. So if you have different, put in different values of x1 and x2, we are going to get different values of utility. So what happens is you can compare you can set up a range of values and rank them like this. Okay, so you have put in different values of x1 and x2, and you get a ranking of u1 is less than u2, u3, and so on. So when you if you take the transformation in such a way that after the transformation, the original ranking is preserved, v1 is less than v2, and so on up till vn, then we say that v is a monotonically increasing function of u. Okay. Now it is also possible to have v prime to be, or f prime over here to be negative. In that case, it will be a monotonically decreasing function. In that case, the function, the ranking gets reversed. The order of the ranking is same, it's only reversed. Okay. Since it adds to the confusion, we generally don't go for a monotonically decreasing function. We generally take a monotonically increasing function. So that means the ranking will be u1, u2, u3, so on. And this will generate the ranking v1, v2. Now note that u1 can be greater than v1, u1 can be less than v1. We are not saying anything about these two values. Okay. So if you have a monotonically increasing function, u1 can be, or rather ui can be greater than vi, or ui can be less than all the vi. We are not saying anything about this. Both of them are positive monotonic transformation. So basically what I'm saying is that suppose this is v1 can be either like this. So v1 is greater than u1, v2 is greater than u2, and so on. Or we can have, in that case, the values of v are less than u. But look, the order is preserved. Okay, so that is the meaning of a positively or monotonically increasing function. So as I've said that we can also have decreasing functions, monotonically decreasing functions, but we generally don't go for that. So when I'm saying that we have undertaken a monotonic transformation, we mean that it is a monotonically increasing function. Okay, is this part clear or will I explain it again?
So, like, could you explain it again?
Yes, sir.
Okay. Okay, so you understand the difference between a monotonically uh, increasing and monotonically decreasing function. Okay, we have a function y equal to and we take a transformation let's put this u also. Oh, I've made a mistake. we take a function and the transformation is, let us say, f of y, which is simply okay. Okay, in case of a positive monotonic transformation, f prime is positive. We have the original ranking. So that means if u1, u3 like this, we are going to have okay. In case of a negative monotonic transformation, f prime is negative, so the ranking gets reversed. So now what we are going to get is z1 is greater than z2 greater than z3 and so on up to zn. Okay, is this clear? Okay. Okay, so we have taken a positive monotonic transformation. For convenience, I'm just taking a one variable function. So let us say y equal to 5x. Okay. So if you put in these three values will do. What is the value of y? This is 5, this will be 10, and this will be 50. Okay. Now let us take a transformation y equal to x, z equal to y square. So this means it's 25 x square. Okay. So what is the value over here? This is 25. This will be how much? 2, 4. This will be 100. This is 3 square. 9 into this will be 225. Right? We go on like this way. Achha. Now, if you compare the values of y and z, you will see that u1 is sorry. u1 is less than z1, u2 is less than z2, u3 is less than z3. Okay, so the value of the index of the function has increased. Okay, so the values of z is greater than the value of I. The ranking is same, but what has happened is all the values of z are greater than the corresponding value of y. Now, let us look at this function. Okay. So this will be simply w is equal to x. So in this case, right? Now what has happened to the ranking? The ranking is same, but compare the values of the index, compare w and y. what do we get? Y1 is greater than W1, Y2 is greater than W2, and so on, right? So both of them are positive monotonic transformation, but you have to be a bit careful. As a result of this transformation, what I'm ensuring is ranking is unchanged. Okay. The value of function can increase. The value of the function can also decrease after the transformation. Okay, is it clear now?
Yes, sir.
Yes, sir.
Okay, so we have taken a utility function and we see that the marginal rate of substitution is the same. So the consumer equilibrium will remain the same for a monotonic transformation. Okay, whether it's a monotonically increasing or whether it is monotonically decreasing. Okay. We have shown, we have looked at the partial derivatives over here, and now we come to production. Okay. SM has discussed what is an expansion path. So suppose the budget of the firm, the allocation and cost increases, but the input prices remain the same. So initially the cost was C equal to WL plus RK. Now we increase the allocation, so it becomes 2C. 2C is equal to WL plus RK. In that case, there will be a parallel shift of the ISO cost line. Okay. And if the locus of the points, I've made it a straight line for convenience, but it can be a curve, any type of curve. So the locus of all tangency points is called the expansion path. Now consider a homogeneous production function. What is the slope of the production function? It is the ratio of the marginal products, FL by FK. There should be a minus, but I've ignored it. It's not. Okay. Now, we know from one of the theorems before that if you have a. Let me find out the theorem. Yes. This is the example. So if you have a homogeneous function, homogeneous of degree n, then the marginal products will also be, yeah. If y equal to fx is homogeneous of degree n, then this is the marginal product is homogeneous of degree n minus 1. Okay, we have proved this before. So now we are applying this. This function is homogeneous of degree n. So the marginal products will also be homogeneous of degree n minus 1. If we simply increase all the inputs in the same ratio, they will be, we can write in this manner. Lambda r minus n minus 1 into FL, lambda n minus 1 into FK. Okay, so this lambda part cancels out. So therefore, if we increase labor and capital in the same ratio, this will keep the marginal rate of technical substitution, the slope of the isoquant, unchanged. So that means if we take a line through the origin, a ray through the origin, the labor capital ratio is constant along this origin. We are simply increasing labor and capital in the same ratio. See, the slope of the isocont at this point at E1 and E2 will be the same. Okay, so if we take any ray from the origin, the ratio of FL and FK, which is equal to MRTS, will be unchanged. Okay, so basically, what will happen is that if you take the isocost, okay, and let us say this is the point of tangency. Now, you increase the allocation, keeping W and R unchanged. So that means there's going to be a parallel shift in the isocost line. So if we increase C, keeping W and R constant, there will be a parallel shift of the isocost line. Now, what does parallel shift means? It means slope of isocost is remains the same. Okay. So that means if I introduce a new increase just cost, this is going to be the isocost line. This is unchanged. Now suppose we had equilibrium over here. Okay, so at E1, you had WR equal to MRTS. Now at E2, the new isocost line, you still have the original WR ratio. So the equilibrium will occur when MRTS is same. Okay, so equilibrium must occur at E2. When we are simply increasing the labor and capital in the same proportion, keeping the labor capital ratio unchanged. So that means the expansion path must also be linear. Okay, we can't, it may be possible to prove it mathematically, but it's mainly an intuitive proof. Okay, so is it clear, everyone? Or will I explain this again? The linear expansion path.
Clear, sir.
Acha. Acha. So we see that the expansion path in this case, if you have a homogeneous production function, then the not only will the ray, that is, we are keeping the labor capital ratio unchanged. Okay. So what we are doing is we are keeping the labor capital ratio unchanged. So we can draw different lines. These are different rays. Okay. So along any of these rays, the labor capital ratio is constant. So as we are moving from, small k1 to k2 and kl, k3, the labor capital ratio is falling. Okay. But along each ray, the L by K ratio is constant. So if you have a homogeneous production function, you will always have this property. If we increase labor capital in same proportion, that is K is constant, okay, so this is labor capital is constant. So over here, the slope of the isocons along the ray is constant. This is the important part. So if you're taking isocons over here, we can draw different isocons. So is constant. Along a different ray, you're going to get a different value of the slope, but again it is going to be constant. Okay. Okay. Now, this property, that is the slope is constant along this ray, is not unique to homogeneous production functions. If you take a transformation of a homogeneous production function, okay, when I'm talking about transformation, I mean a monotonic transformation. So if you take a monotonic transformation of a homogeneous production function, which has a linear expansion path, then this is called a homothetic production function. So a homothetic production function has got two properties. It is a it is derived from a homogeneous production function. It is simply a monotonic transformation of a homogeneous function. And secondly, the expansion path is linear. So any function which satisfies these two properties is called a homothetic production function. Okay, so that means, okay, this has some very interesting properties. Let's look at the second property first. The expansion path of the homothetic production function is linear. So we consider a homogeneous production function. It's homogeneous of degree n, y equal to f as a function of labor and capital. And if we take a monotonic transformation, we can write z equal to f of y, which can be written in this manner. So what is FL? FL is del f by del y. See, del f by del y. But y is a function of L. So y is a function of L. L changes, this changes y. When y changes, f will change. Okay. Now we can write this as f prime, and this is simply marginal product of labor. Similarly, the marginal product of capital in case of the transform function is capital F prime into NPK. So what is the slope of the transform function? MRTS is F prime NPL by F prime NPK. So this is equal to NPL by NPK because the F prime cancels out. So we have, but this is the original marginal rate of transformation, the slope of the original production function. Okay. Now, since MRTS is constant for a constant labor capital ratio, MRTS of capital F will also be constant as long as labor capital ratio is unchanged. As we are moving up like this, okay, Y has the same slope. We have proved that Y and F has the same slope. So that means here we have taken F. F will also have the same slope. The slope is unchanged. As we move up like this, we are simply increasing labor and capital in the same proportion. The MRTS or slope of the transform production function is going to remain the same. Now over here, I want to make a distinction which SN has probably already made. Okay. Okay. Let me first look at what is returns to scale. So this is a constant labor capital ratio. So suppose we have and we increase labor and capital in the same ratio. So we are increasing labor by lambda L, capital by lambda K, which implies that K is same, constant. So we are moving up like this. Now obviously, we are going to have some isoquants over here. Let us say this is Q1 is equal to 100. Now, let us say that lambda is equal to 2. So we are basically, we are doubling the use of inputs. Okay? Keeping k small k constant. Achha. So if you are doubling the input use, how much will Q go up? This is a homogeneous production function. Okay? Homogeneous of degree n. Okay. So in that case, let's take the simplest example first. Y was, or let us put it Q was Lk equal to 100. We have doubled inputs. So it is 2L by 2K. And now let us say we are getting an output of 200. So what is the value of N?
1.
1.
So N is equal to 1. This is called constant returns to scale. Okay. So that means if I'm going to double input, so I'm just drawing this for labor, otherwise it's going to be very, okay, let me draw it for. So this is a case of a constant returns to scale, which corresponds to N equal to 1. Okay, is it clear? Okay, shall I wipe it out?
Yes, sir.
Okay. Okay. So again we have this is K. Okay. Let me copy this, okay? So I won't have to do it again. Now, another possibility is that we started off with Q equal to FLK and we got 100 units of output. When we double the labor, the output increased to 300. So in this case, n will be greater than 1. We don't know what is the precise value of this. You'll have to calculate. But it's intuitive that it will be n will be greater than 1. Right? So output is increasing, but it is increasing more than your input. Your input, if your input doubles, your output will increase, will more than double. If you increase your input 3 times, output is going to increase, let us say 4 times, 5 times, something like that. This is called increasing returns to scale. So in this case, this will be okay. And finally, we consider the case of decreasing returns to scale. So what will be the value of n?
less than
But it will be greater than 0. Output will not decrease. So this is 100. This will be 200. Let us say it will be 150. So output increases, but by less than lambda times. Okay, is this clear?
Yes, sir.
Okay, so remember the gap over here is the same because how are we measuring the gap? By L and 2L, K and 2K. Okay, so this gap will remain same. The difference between increasing and decreasing is, let's see, this is in both cases we are starting from 100. When we are moving the same distance, we are able to move to 300 over here. Here we are moving to only 150. I think SM has already covered this, right? Okay. Economies of scale is also a case of input use. So we are increasing labor and capital, but now this is the important point. But not in the same ratio. So an example is that labor is, let us say, 50, capital is 75. Okay. So in now we are increasing. Sorry, wait a minute, please. I'm having a problem. So okay, let me explain this. For some reason, I'm unable to write. So suppose your labor and capital was 50 and 75 units. If it was a case of returns to scale, you would have increased both of them in the same ratio. So if you would have made it, if suppose labor was 100, what would be capital? Yes,
150.
150.
150.
150. But here, if you're increasing labor from 50 to 100, you can keep capital constant. You can increase capital by 150. You can make capital 500. You can do whatever you like with capital. Okay, you don't have to keep the labor capital ratio unchanged.
So, but it can only be done when we have enough profit and enough production after a certain point of time.
Okay, wait a minute. I'll just switch off. I have to start again. Okay, so economies of scale is you have increased use of inputs, but not in same ratio. So that is K can vary. So suppose your labor and capital was 175, you make this 200, 400. Or you make it, this is double, but it is increased to only 100. So in this case, capital labor falls. In this case, capital labor increases. Okay. How will output change? Output will obviously go up, but this is the important point. Look at what is happening to average cost. So this is total cost by quantity. We can have three situations. One is average cost is rising, average cost is same, and average cost is falling. Okay. So this is called, you have economies of scale. Here you have diseconomies of scale. And here the economies of scale balances with diseconomies of scale. Okay, the two balances out. So basically what we are saying is what happens if your production increases. You can also conceptualize this in terms of, well, not marginal product, because it's going to, you can't, no, you have to look at only in terms of average cost. So that means you can think of in this way. I'm making a very crude diagram. Sorry. So we call this economies of scale, and we call this portion diseconomies. And obviously this is a portion where it balances. Okay, so what is the main difference between economies of scale and returns to scale? What happens to small k? If a small k changes, this is a case of economies of scale. You're simply increasing output and you're seeing what is happening to cost. But if you have a constant labor capital ratio, then it is a case of returns to scale. So you look at what happens to, this is a very special case of the economies of scale. Okay, but here again you can also think of it in terms of cost, as I'll show it to you now. So the reasons for economies of, there are many reasons why you have economies of scale initially, why you have diseconomies later on. I'm not going into the discussion because it's better covered if you in a micro class. But if you read any standard textbook, I'm sure that you'll find the explanation. Now over here, let us look at one thing. Okay. This is marginal cost. Output is changing when cost is changing. Now suppose your function is like this. Okay. So in that case, y has q changed? The reason is L has changed. Okay. So if L has changed, you can set up a flow chart. If L changes, then Q will change. And as a result of this, L change, cost will also change. Okay. Now, why has cost changed? Are you employing more capital? See, input prices are same, right? So why will cost increase?
So the number of labor has changed.
Yeah. So your input use has changed, has gone up. If capital is constant, then the change in L is the reason for the increase in cost. So what is the increase in cost? It is simply W into del L. We can write this. Okay, so over here what we can do is dc by right. The change in cost is W into dl. Now if I just bring W down, so what is this? But simply W divided by MPL. Okay. So this is a small theorem which is very useful, and you will require this subsequently in different cases later on. Okay. Now, what I want you to do is let us take a Cobb-Douglas production function. So this is homogeneous of degree. What is the degree of homogeneity?
1.
It is a linearly homogeneous production function. And let us take a positive monotonic transformation. Okay. Let's call this Z. So what is Z equal to? See, note over here that F prime, what is F prime? It is 1 by Y, which is positive. So this is a case of what we had said to be this type of case. The value of the function is decreasing. Okay, so if you put in labor and capital over here, you're going to get Y. If you put labor and capital, the same labor capital over here, because you're taking log, Z will be lower than Y. But the ranking is unchanged. That is why we are calling it a positive monotonic transformation. Okay. Okay, so if we break it up, we are going to get this will be how much? 1 minus alpha log of K. Right. Now, what is the degree of homogeneity of this production function?
We don't have.
Yes?
I don't think
What
so
is the
much.
degree of homogeneity of this production function.
It won't be a homogenic function, I guess.
It will be a let us put in the values of increase the values of L and K. Okay, so what is Z? Or rather, let us put it, what is Z1? Alpha okay. So can you take lambda common? See over here, if you increase it by lambda, lambda is going to come out over here, right? You are going to have in the original function, you are going to have y1 will be lambda, but here can you take out lambda? Can you take lambda common? So if you want to find out what is Z1, you will have to actually put in the values over here and find out. So this implies that Z is not a homogeneous function. Okay. So, so this is a homothetic function, right? Because we have taken a positive monotonic transformation of a homogeneous function. But Z is not homogeneous. Okay. Let us look at the second property. Let us look at the expansion path. What is the expansion path of the original production function? Sorry, the A should not be over there. This is MPL কত হচ্ছে তোমার alpha, sorry এটা তো তোমার হচ্ছে তোমার alpha key is 1 minus alpha. Okay, so it is alpha L alpha minus 1 key 1 minus alpha. What is MP key? 1 minus alpha L alpha key 1 minus alpha minus 1, which is minus alpha. So it simply becomes okay, this is minus alpha, so it becomes L সরি এটা মাইনাস আলফা হলে এটা মাইনাস এন হয়ে যাবে। It is L by K.
So it is coming K by L.
হ্যাঁ সরি আমার এই অ্যাটেন্ডেন্সটা দিতে এটা ঢোকাতে গিয়ে আমার গোলমাল হয়ে গেল। ইট ইস কে বাই এল। আচ্ছা ওকে পার্থিব, can you hear me? Please unmute yourself. Parthiv, Thriti, and Akila Shakil. Please unmute yourself and answer this question. What is the expansion path of the transform production function? I'm sure you have been attending the entire class very confidently. So, you know what is an expansion path, right? And what is a homothetic production function? Bolo Mohor, what is a homothetic production function? Please unmute yourself and answer. Mohor, can you hear me? আচ্ছা তুমি পালিয়েছো। আচ্ছা পার্থিব, unmute yourself please. আচ্ছা ধৃতি কর্মকার, ধৃতি কর্মকার, please unmute yourself. আকিলা তো আগেই পালিয়েছে। Okay, so if you are not present is I'm removing you from the classroom. Okay. Okay, so if we look at the transform production function, what is the MRTS? If we look at the transform production function, what is the MRTS?
So it is the same as in the previous step.
Yeah, it is MPL টাই বার করে নি। Yeah, so we'll get this as alpha 1 minus alpha K by L. So MRTS is the same.
So the NPM will be alpha Z by L.
না না আমি করিনি, ওয়ার্কআউট করিনি, জাস্ট লিখেছি। Okay, so you can work it out yourself. If you have any problem, you can ask me. I'm sure that you've worked out the assignments. আচ্ছা, so I want to close with
Sir, 1 minute, sir. লিখছি।
yes.
So, okay, that page.
হ্যাঁ,
স্যার
হুম,
Sir, sir, out there, the second MRTS is for Z, no?
it is for Z.
Yes, sir.
স্যার বলছিলাম যে ওই রেফারেন্সের জন্য আপনি বলেছিলেন না ওই সিলভার আর সুয়েনের যে বুকটা,
হ্যাঁ,
তো বলছিলাম স্যার ওইটা কি আমাদের পরবর্তী সেমিস্টার গুলোতেও লাগবে নাকি না ওটা শুধু ফার্স্ট সেমিস্টারের জন্য?
না ওটা তোমরা সফট কপি নিয়ে নাও,
আচ্ছা।
তোমাদের পরের সেমেও হয়তো লাগবে, এমডি কিছুটা করাবে, কিন্তু এটা কিনতে যেও না।
তাহলে স্যার মানে চিয়াংটা কিনেছি, তাহলে স্যার আর আর কোনটা দরকারি মানে?
চিয়াংটা কেনো, হয়ের বই, হয়ের বইটা কেনো।
আচ্ছা, ওই ম্যাথমেটিক্যাল অ্যানালিসিস।
হ্যাঁ, ব্যাস।
আচ্ছা,
These two are
বিনমোড।
sufficient. No, Binmore you will need only the first part. You won't need in the coming semesters. So Binmore, Silverberg, and Swain.
Sir, I have searched whole College Street and also online. I did not get Hoy.
What
Yes,
did you
sir.
say? I didn't. I beg
I
your
Not
have
pardon.
been
getting high
searching
anyway.
the entire College Street and also in different online platforms. I am not getting
For
Hoy.
Hoy.
Yes,
Yes, sir,
that,
Hoy isn't available.
and in Amazon there is a foreign edition which is 23,000.
Phew. দেখো সফট কপিটা তো এখন পেয়েছো, keep
Sir,
that.
could you resend the soft copy?
I'll
Sir,
send you the link. Yes.
Yes.
sir, how is the seat setter and hammer that book?
Yeah, Sitseta Hammond also you can, we'll give you some problems, but you don't have to buy that book. Sitseta, Bloom and Simon, এগুলো, if you keep soft copies, that is all.
Sir, মানে ওগুলো তো জাস্ট টেম্পোরারি ওই at that some
হ্যাঁ মানে আমি হয়তো maybe I'll
specific
teach one page from that, one problem, এরকম হয়, like this.
আচ্ছা
Because
তাহলে
second sem, Chiang is going to become very important. I will continue with Hoy in integral calculus. But
So
even
we
in this
have to
semester,
purchase Shank.
yes, purchase Chiang.
Chiang and Hoy.
Hoy you're not getting, so you can't purchase it. Purchase Chiang.
Sir, actually I got it printed. It costed less.
Yeah, I think that will. If you want, I can identify the pages of Hoy or the chapters of Hoy which are
Yes,
used.
sir. So I
Yes,
will.
sir.
What is the current edition? Like I have the
Third,
third edition of Chiang. Okay,
third is common. In Chiang also, I think Chiang and Wainwright, fourth edition.
ইয়েস স্যার।
yes.
Yes, sir.
Achha, okay, just let me finish this part and I'll close today's class.
Sir,
Yes.
sir, before ending the class, sir, could you explain that better and worse set concept once again?
Better
I
and
went
worse.
through the
Okay,
videos.
okay,
So
I'll
still
do it,
don't
but
understand.
let me just introduce this concept. So, elasticity of substitution is a case when uh, see over here you have got a labor cap, you have got a price ratio, and this is another isocost line when your price ratio WR ratio has changed. Okay, so input price ratio has changed. The price of L has W has gone down over here. So what will happen is E1 and E2. So when W decreases, we are going to have a new equilibrium And it's very obvious that in most cases, the labor capital ratio will be different. Okay, so given that wage has become cheaper, since wage has gone down, we can expect that labor use will go down and we are going to have more of capital. So we are going to substitute the cheaper input, which is capital, for labor, for the costlier input. Okay. So small k is going to change. Now, the elasticity of substitution sigma is the relative change in small k divided by the relative change in the input price ratio. Okay. So this is simply dk by dk, and this is wr by wr. So we can write this as dk by dwr. This is the elasticity of substitution.
So,
Yes.
but I guess SMS wrote it as MRTS. Like we can replace MRTS, right?
Yes, sir.
Yes.
Uh, Over here, you can put in MRTS
Yes, sir. So,
because at equilibrium, we know that W by R is equal to MPL by MPK.
Yes,
But
sir.
so that is
Yes.
simply a way of writing it. So instead of W by R, you can write MRTS. But I mean, this is the, you start the definition with like this. Okay. But you can certainly put in MRTS over here. But I would say don't put in MRTS because see what if you look at the definition, the logic behind writing this MRTS is that your input price ratio is changing. If you write MRTS over here, you can't see whether input is changing or not. See, why is the change occurring? Because of a change in MRTS or because of a change in the input price ratio?
So change in input
change
price
in input
ratio.
ratio.
Yeah.
Input price ratio.
So in this way, you can understand the mechanism why the elasticity of substitution is important.
So basically, sir, when we
Yes, sir.
write the definition, we'll write from what you have given.
Yes, I would suggest it because in that case, you will be able to understand why small k is changing.
So here if wage goes down, then how is input K being cheaper?
K is the capital labor capital ratio.
So I mean capital K in the third line, like as wage goes down.
Actually, here my the way that I've drawn it hurriedly, so without looking at. Uh, oh, sorry. Yeah, ঠিকই বলেছো তোমরা। এইখানটা আমার একটু ভুল হয়ে গেছে। লেবারটা বাড়বে, ক্যাপিটালটা কমবে। So labor use will go up, capital will come down, labor costlier input. 8. Yeah, you are right, perfectly right. And however, I would also ask you to be strategic. If SM has defined MRTs in that way, in her exam, you should write the way that she has told you. Okay, there's no need to go for controversy. But in my class, or when you define it outside in interviews, if you ever ask this question, you should use my definition. Not my definition, but the standard definition. Okay, so I'm ending the class as such, but I'll just finish off with better and worse set. See, better set is,
Sir,
huh,
sir, you told that you will explain the syllabus.
হ্যাঁ আমি লিখে আমি করে দেবো, কৌশিক বাসুটা হয়ে যাক।
ঠিক আছে স্যার, ওকে।
See, this is u equal to, let us say, u1. A better set is, see, that means that any combination over here will give you the same level of satisfaction. Along an indifference curve, you have the combinations of x and y2 which yields the same utility. If it is an isocont, it is a combination of labor and capital which gives the same output level. Okay? We call this a level set. A better of set is when the combination of x1 and x2 gives you a higher index value. So that means it will give you a higher level of utility. The labor capital ratio will give you a higher output level. So combinations like this. Combinations like this. Okay, these are all points in the better set. So such points lie in the better sets. So what will be the worst of set?
So below that.
Below that.
Below that. So that means the
Below
x and the commodity basket or input combination
So because it provides lower satisfaction.
will give you a lower index value. Utility is either lower or a Q is lower. Okay. Satisfied?
Yes, sir.
Yes, sir. So,
No, I'm
so could you show example like how to find that quasi concavity and concavity using the better set and all?
not today then. Remind me tomorrow because you have a class
Yes,
from
sir.
11.
Yes, sir. Thank you, sir.
Yeah, yeah. Okay.
And sir, can we have the
Thank you,
revision
sir.
from next week?
ঠিক আছে, আমরা ফ্রাইডেতে মিট করে আমরা বলে দিচ্ছি।
Hello.
থ্যাংক ইউ স্যার।
Thank you,
Thank you,
sir.
sir.
Thank you, sir.
Sir,
Oh, sir, are you here? Sir, are you here? Sir, I was asking about the revision classes.